on our announcements, we have mastering tonight, Monday and Wednesday of next week. Your first exam is coming up. We're going to do a group quiz today, individual quiz on Monday. And if you're getting a little overwhelmed, the chemistry help room is now open. It's in back 254. It's open every day from like 9 to 4. There's a few gaps in the middle there, but in general 9 to 4. And they are great for like drop-in questions. Like if you have a question on mastering chemistry, you're working on it, you can't find me, just pop in there, they can help you answer it. Or if you are reading through your notes and like, man, I have no idea what she's trying to say here, and you can't find me, pop in there, and they can help work it out.
When are they open?
In general, 9 to 4. Some days earlier, so there's, I think 2 days a week, they're going to open at 7, and a few days they stay open until 6. So, all right. All right. So we're going to finish chapter 7 today, start 8 on Monday, finish 8 by a week from today, do a review, and a test. Yay. Okay, so let's look back. Oh, before I forget, the other thing I need to tell you. For lab next week, you must absolutely have your goggles, your lab notebook, and your own lab manual. You cannot share any of those items. Everyone has to have their own individual notebook, goggles, manual. They will send you home from lab next week if you don't have all 3 of those items. I know we're not doing anything dangerous, but in general, we just need to get in the habit of wearing those things. Oh, and you'll have a pen. And your pre-lab questions, your first set of pre-lab questions will be due when you walk in. So don't forget to do those pre-lab questions over the weekend. I think there's like 3 or 4 pre-lab questions. Yeah. No, they are in the lab manual. They're on page 14 of the lab manual. So when you're reading the lab, there'll be like pre-lab questions, a little heading, and be like, I think the first question is like, describe the difference between a hobby and a science, something like that. So they're not super tricky questions, just kind of warm up. So that's my public service announcement. Don't forget to do that. Depending on who your lab instructor is, they will not accept it after lab has started. So, all right, so let's talk quantum numbers. So where we left off on Wednesday, we had talked about the principal quantum number, which is n. And n tells you about the overall size and energy of an orbital. N can only be whole number values because electrons can only be found in one or the other energy level, can't be found in between. As the value of n increases, the energy increases. But the energy increases, energy differences get smaller, the higher energy you get. Based on n, we can then describe L. L is the angular momentum number, and that determines the shape of the orbital. L is only allowed, again, whole integer values between 0 up to n minus 1. I looked at these examples, right? If n is 2, has 2 options of L. N is 5, we have 5 options of L. And an L is a number, is a letter. So if L is 0, that's S. If it's 1, it's P. If it's 2, it's D. If it's 3, it's F. And each one of these letters or numbers or whatever refers to a shape.
So L can't be more than n, right?
Correct. It cannot be more than n. It can't even be equal to n. So I couldn't have, I can't have n equals 2 and L equals 2. They can't be the same number.
It has to be 1 or...
Yes. Yep, always has to be less than. So each one of these letter number values of L tells me about what shape we have. All right, so this is where we left off. All right, so each one of these letter values of L tells me about what volume shape I should look in. So if I have L equals 0, which is the letter S, that tells me it is a sphere. But I should be looking for the electron in this sphere around the nucleus. That's where it's most likely to be found. This is the lowest energy, which makes sense, right? Because if L is 0, it means N is 1, which is the lowest number N can be. So if L is 0, that's the lowest energy. And it's a spherical shape. All right, if L is equal to 1, all right, that's the letter P. And P can have 3 options of shapes. All of these are P. So if N equals number 2 or greater, you can have L equals 1, which means you have the P orbitals available. And it has 3 possible shapes. So we have this shape, which is across the x-axis, this shape across the y, or this shape across the x. Where this is the probability of finding the electron. What's weird about that, you can think about this later, it means I have some probability of finding it on this side, I have some probability of finding it on this side, but if you look, there's a gap. There's 0 chance of finding it in between the two. How the heck does the electron get from one side to the other? Because it can flip back and forth, but it can't go through this middle. Whoa, right? So it's like a wave / particle. It's a particle if it's in the volume of space, but somehow it can jump from one spot to the other spot without going through the middle. Crazy. Electrons are crazy. You can think about that. You can think about how crazy that is.
What planes did you say those were?
Oh, this is in the X, the Y, and the Z. Yep. One of each. Okay, if L can equal 2, which is the letter D, it can now have 5 options of shapes. So these become available when N equals 3 or greater. All right, so if N equals 3, then I have the option of L equals 2. So it becomes available to the electrons. And 4 of the 5 make total sense, right? So you can have dumbbells crossing each other this way. You can have dumbbells crossing each other this way or that way. This one's kind of crazy, right? Doesn't look like the other 4. But the thing to remember is that each of these have the same volume. So all shapes with same L value are of equal volume. So even though this one looks different, it fills the same amount of space as the other 4. Which means the probability of finding the electron is really all equal. Question?
Where you when N equals 2 or greater?
Yep.
Then it can have
L equal 1.
L equal 1?
Yep.
Okay. As far as it like being 2 or greater,
Mm-hmm.
so it's anything between like 2 and 3, because if it's 3 or greater, it's D.
You can still have, if I have N equals 3, that means I have this option and that option and that option.
Okay, so it's just like choose one.
Mm-hmm.
Okay.
If I have L equal, or if I have N equal 1, this is my only option. If I have N equal 2, then I have this option and that option. If I have 3, I have this option and that option and that option. So the more energy I have, the more ways I can arrange myself. I have more energy options.
Why does the 0 have a line through it?
What does 0 have? Because that's how I write my zeros, to make them not look like O's.
Oh, so doesn't make anything?
No, I just try, because we use so many letters, I try to make my 0 look like a 0.
Oh, okay.
So I try to make all my zeros, but Just like my 7s, I try to put a little line through it so you know for sure it's a 7, not a messed up letter.
Okay.
So, no, there's a lot of letter numbers, so I want to make sure you know which one we're talking about. Okay, good. So, I feel like there's that weird thing. Is that better? Maybe. All right, so that is L. So now we have 2 of the 4 quantum numbers. The next quantum number is the magnetic quantum number. So this again should be a little scripty L. That should be that guy. So the magnetic, oh yeah, question first. Oh. F would have 7 options of ways to draw it. I just don't have a good graphic.
Okay.
But yeah.
But
F,
it still is.
mhm, yep.
Now, you're saying ways of drawing it. Would that be 7 different planes it could be on?
Not planes, it'd be 7 different ways to arrange the same volume across 3-dimensional space.
Okay.
Right, so it's easy when it's this way, this way. But now I have to do 7 shape gets tricky. All right, so M sub L tells you the orientation of the orbital. All right, so we just said that if L equals 1, I could have it up and down, I could have it this way, or I could have it that way. M sub L tells me which one it is. Tells me which one of those 3 options it is. So M sub L depends on the value of L, all right, and L depends on N. So they all depend on each other. And M sub L can have integer values between minus L to plus L. So you did some of this on your homework for Wednesday night. The idea is, hopefully if you saw it a little bit, then when we go over it, you're like, oh, totally got it. It was intentional. All right, so we can have these values. So let's look at some examples mathematically, and maybe it'll make more sense. All right, so let's say I have, let's say I have an n value equal to 1. What can my L value equal? 0. So what can M sub L equal? Just 0. Good so far? Good warm up? Everyone feels confident? Okay. Let's try. We'll go in some baby steps. We'll do n equals 2. All right, so what are the possible values of L then? 0 and 1. I'm going to write them out separately. You could write them with commas, that'd be fine, but it'll make sense here in a second. All right, so let's say I have n equals 2, L equals 0. What could M sub L equal for that combination? 0, and then over here I heard it, minus 1, 0, 1. So the M sub L depends on the L, which then depends on the N. So how many different ways can I arrange this volume of space? Just one, right? Which makes sense, because if L equals 0, which equals S, it's a sphere. There's only one way to draw a sphere, spherically, right? So if I have L equal to 1, which is P, I can draw it 3 different ways. This way, this way, this way. 3 different ways I could draw it. Hopefully some light bulbs are going off. Oh, I get it. What if I did, I wrote real big, I didn't mean to. If I have n equals 3, L equals 2, what are my options of M sub L? Yeah, plus or minus 2, however you want to count it. How many total orientations is that? 5 orientations. which makes sense. Now, the m sub l, you don't need to know that the -1 is in the x direction or the 0 is in the y. I don't care about that. Know that there are 3 ways to write m sub l for this, which tells me which direction the volume is going, right? So if I have 3 options, these are the 3 different ways I could draw it. If I now have 5 options, these are the 5 different ways I could draw it, and they're dependent on the L, which is in turn dependent on N. So the more energy I have, the more ways I could draw that volume, the more orientations I have. They're all kind of interrelated. So in terms of lingo, we're going to have very specific lingo when we talk about how am I describing what's going on. So the principal level, which is N, tells me about energy. So if I'm in, this is going to be important when you do your tests and quizzes because I'm referring to it as the appropriate science phrase. So if I say, what is the principal level of N equals 2, you're going to tell me 2. That's the principal level, 2, as I told you. If I'm saying the sublevel, I'm saying what L value does it have based on the N. So if I have N equals 1, the only option of L is 0, which is S, which calls it the 1S sublevel. Or I could have N equal 2, so now I have 0 or 1 as options. Or N equals 3, I have 0, 1, 2 as my options. If I say the orbital, I want to know the N value and the L value and something about the m sub L value. So depending on which question I ask, I'm asking different amounts of information. Principal level, I just want to know the N. If I ask about the sublevel, I want to know N and L. If I ask about the orbital, I want the N and the L and the m sub L. All right. So, describing when we describe an atomic orbital, we refer to it with shorthand. So if I have 1s, that first number tells you the value of N, and the second one tells you about P. The P tells you about L. Sorry, I'm thinking ahead. Thinking the next one over, my next example. So N and L. So by using a combination of letters, numbers, I told you N and L together. If I tell you that it's the 2px, I'm telling you 2 is the N value, P is the L value, and the x tells you that it's only one of the 3 m sub L values. Sure. 2 is the N, P is the L, and if I didn't have an x on here, I could be referring to any, there's 3 different options. By saying x, I'm saying just pick one. Pick one option for m sub L. Yeah? Mm-hmm.
You wanted to be specific and refer to...
No, just means pick one. So if I didn't, so let me do it this way. We'll do 2p versus 3dxy. So if I'm saying orbital, I'm saying I want the n value and the L value and something about n sub L. So if I have 2p, what does n equal? 2. So n equals 2. If I have p, what value is L? If I didn't tell you anything else, what are my options of m sub L? Minus 1, 0, 1.
Okay, wait, how did you know that L was 1?
Because it's p. P is 1.
Oh.
All right, this one I've given you more information. I say it's a 3D XY. So what is the value of n? 3. What is the value of L? 2. And then here, just pick any one correct value for m sub L. Sure, whatever you want. Write down any correct answer between -2, -1, 0, 1, 2. All of which are fine. For us, if you're going to take PChem, I would care. But we're not. We're in general chemistry. So any one of those 5 options are correct for us. So whichever number you like. I like 0, so I'm going to pick 0. That's fine. So this is shorthand that tells me all this information. So in your head, you should be able to go back and forth between these. If it's 3D XY, in your head, you're like, n equals 3, L equals 2, m sub L equals 0. Or maybe I give you these 3 pieces, and you go the other way. If I say m sub L equals 0, L equals 1, n equals 2, you tell me, oh, that's the 2p orbital. Be able to go back and forth.
Why on that is it doesn't respond, and on the previous one it was just X, doesn't matter.
Oh, it's, when I have a d orbital, I describe it, so this one bisects both the x and the y plane, because there's 2 different dumbbell sections. So in this one, it's just going, there's just 1. Now I have 2, I have to tell you both directions. So a little bit of geometry. So, okay, how are we doing so far?
So when it gets more technical, just looking at the previous one, so what the X and that stuff, or X, Y, represent actual,
It does technically represent just which one it is.
Okay.
We don't care that much. Any one of the 5 would be fine. Yeah.
Right, I understand this.
Yeah.
But if you are referring to a specific orbital, could you say 3D -2?
3D, no.
No, you don't put X, Y?
Mhm. Whoever developed the shorthand wants to use the geometry letters rather than the m sub L number. I don't know why they chose that. That's what they did. So,
Do you want me to be specific?
well, the idea is that if you really cared, you would use the right geometry numbers, letter combination, so that the other person's in 3D space thinking about it the same way you are.
Oh, okay.
So, yeah.
So what's the difference between the X, Y, and
X
X?
only refers to P's. If I have 2 letters, it means I must have a D.
So are there like F sub values, 3 letters?
Mm-hmm. Because they're in all 3 planes. Yeah. I can't find a good picture of it, so I don't know if nobody's tried to draw it, or it's just too complicated for me. So, but yeah, they would have 3 letters, because they'd have some portion of their orbit in all 3 axes. So, all right, have I confused everybody? More confusion to come. Good. Let's talk about the 4th quantum number, and then we'll put it all together. All right, the 4th quantum number is the magnetic spin number, and that tells me about the spin of the electron. Get my right page notes. So in an orbital, an electron can either spin up, which is given an up arrow, or down. which is given a down arrow. So it can only spin this way or that way. Again, for R, it doesn't make any difference to us. Unless you want to take some more chemistry, in which case we can talk about it some more. But these are going to spin towards you or back. You can think about it like counterclockwise, clockwise, whatever 3D thing works best for you. So spin up or spin down. Spin is a property of all electrons. So all electrons are always spinning. And all electrons have the same amount of spin to them. So even though an electron's in a different energy level, if you're comparing two electrons, they are spinning the same amount. So the spin doesn't change based on energy. All electrons spin the same amount. And the value of m sub s are either plus 1/2 or minus 1/2. Those are our only two options. So, how do we incorporate that into everything else we know? Excellent question. I'm glad I asked it. I'm sure you guys were asking it yourself. I was just asking out loud. So only 2 electrons can occupy an orbital. So if we think about, which makes sense, right? You have 1 up, 1 down. You can't have an odd number. You want them to kind of cancel out. So you have 2 in one orbital. So let's work through some problems and they'll kind of come together. So let's say, I'm going to flip my page over just so I can write bigger, but it's the same idea. Let's say I have, what was my problem from this morning? Because it was genius. If I do say so myself. Let's see here. I guess I'll just come up with another genius one because I can't find it. Ah, here we go. So another way of saying what I just wrote. Yeah, I just ran out of space. So, for each m sub L, there can only be 2 electrons, right? So each orbital, or each m sub L value can only have 2 electrons in it. So let's take a look at, let's say I had L equals to 1. What are my possible values of m sub L? Okay. -1, 0, plus 1. So how many different orbitals have I made? 3. How many total electrons can be in 3 orbitals? 6. Each of these can have a value of plus or minus 1/2. So 6 total electrons can fit in those orbitals. Where each one can only hold 2, but I have 3 different ways of drawing it. So altogether I could put 6 electrons in there. All right, what if I had We'll go up one. Let's say I have L equals 2. What are my possible values of M sub L? Okay, yeah. So how many total electrons can I put in there? I can put 10. 10 electrons. I can have less than 10. Maybe all the orbitals don't have 2. That's fine. But I can't put any more than 10 in there. 10 is the maximum capacity. Yeah.
What do you count? Are you counting the spin?
Yeah, so I have 5 different orbitals, and each orbital can hold 2. So if I have 5 orbitals, each can hold 2, I must have 10 places for them. Okay. So how do we pull this all together? Again, I wrote really big. I'm continuing on the same thought. Same thought. Maybe if I do it like this. So this all comes together under the Pauli exclusion principle. The Pauli exclusion principle states that no 2 electrons in the same atom can have the same 4 quantum numbers. So no 2 electrons in the same atom can have the same 4 quantum numbers. Because the 4 quantum numbers are describing to me exactly where to look for a single electron. So I can't have 2 electrons with the same number because then they'd be in the same spot. So how many people have been to a concert lately? Some sort of event, they had a ticket, right? So if you're thinking about your ticket, let's say we went to some real big deal concert. I haven't been to one lately. I'll embarrass myself when I say the last concert that I went to. You were like, who? Yeah, they were really popular when I went to go see them. It was Garbage. Yeah, real popular band. Mm-hmm. Saw Everclear. That was a big deal. Yeah, not much for concerts. I'd rather just listen to it on the radio. I guess I did see Blues Traveler, and I saw Counting Crows. It's one of those things where I really love their music on their CD. In real life, they're totally a jam band. And so they start playing the music, and you're like, oh, I totally know this song. I'm going to sing along. You're like, nope, I don't know it anymore. Because it goes from like a 3-minute CD cut to a 30-minute improvisational music kind of thing. And I don't like it. So I just stick to listening to my CDs, which no one listens to CDs anymore. So I can't be bothered to get an iTunes account. It's a lot of work. So I just listen to the radio. Because if you listen to the radio, they have to do all the work. They got to choose the music. I just listen to whatever's on. That's fine. Back to my point, that I did have one. So let's say you have your ticket. Imagine you're looking at your ticket, and you are first in level C, right? So that tells you where in the stadium to start heading to. That's the same as thinking about N. Right? So that tells you where in general you should be looking for your seat. You're either really close to the stage, kind of close, farther away. That at least tells you what zone to look in. All right, so now you're in level C. Oh, so in C, I need to find section 301. All right. It is. It's a huge stadium in my head, gigantic. I am going to go see the Pittsburgh Steelers play the Falcons in a few weeks. So, not because I like the Falcons, because I like the Steelers. Technically, I'm a Buffalo Bills fan, but I'll make an exception. Bills don't play the Falcons. So we're going to go see the Steelers instead. I'm sure we're going to get booed with our yellow and black and our terrible towel and whatnot. It's all right. All right, so let's say I'm in section 301, right? That's my L. So that tells me within this section what volume of space to look at. Now I'm looking for my specific row in the section. So now I have my energy level, my in general volumes, my 3 options of volumes. This tells me which one of the volumes to look in. And I have 1 unique seat. All right, no one else in the stadium should have a ticket with the same combination of items. Everybody should have their own ticket and be sitting in their own seat. Same thing for an electron. Each electron gets 1 spot. Can't be in someone else's spot. It has to be in 1 spot. I may have taught this once or twice. I've gotten better. All right, so, question first.
So based on this, in each orbital, you have 1 electron spinning, positive 1 electron spinning.
Yes. So if I'm looking at if I'm looking at like a double dumbbell,
They're going like
yeah, like that, yeah.
yeah.
It's pretty crazy. All right, so let's do, I think I have 2 or 3 practice problems. And then I'll make sure you guys have enough time for your quiz today. Wouldn't want to shortchange you on that. All right, so let's talk how many orbitals are there if I know I have 2p. That sounds like a funny sentence. I don't have 2p. I have the combination of things, 2p. All right, so how many 2p orbitals are there in a given atom? First question, what does the 2 tell me? Okay, so I know n equals 2. What does the p tell me? L equals 1. Am I done? No, because I want to know about orbitals. So I need to know about the m sub l's. What are my options of m sub l's? So what's the correct answer to this question? 3. That's how the homework's going to try and trick you. It's going to ask how many orbitals there are. And you're going to want to put in -1, 0, 1. No. 3. 3 options. That's it, just 3. Okay, what if I want to know about how many electrons I can place in the 3D sublevel? So it's asking how many different ways I can arrange the electrons. So what does n equal? Okay. What does L equal? Okay. What else do I need to know in order to count electrons? I need to know how many orbitals possible. Maybe you know already that L is 2. You can picture the shapes. But if you don't, that's fine. Just count them out. So how many orbitals are there if I have 3D? Right, I have 5 total, so how many electrons can I have? 10. So the answer to this is 10. 10 electrons. All right, how about we do one more? We'll do a challenge. And then for real, I'll let you have enough time for the quiz. All right. Where's my challenge question? Here we go. All right, I think you guys, oh, sorry, I want that one to be 3 and this one to be 6. All right, you guys have got it. So the first question is, how many orbitals do I have if n has a value of 3? So if I have n equal to 3, what are my options of L? 0, 1, and 2. What else do I need to know in order to find out number of orbitals? I know the m sub L. So, all right, that's 0, because we've done these a bunch of times now. So how many possible orbitals are there altogether? 9. There are 9 possible orbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 orbital combinations. Okay, here's the final challenge question. Feeling good about it. All right. What if I now am in energy level 6? Super energetic. What are my possible values of L? Yeah, 0 all the way up to 5, right? Right, I could go through and count through all the M sub L's, right? So if I'm at 0, M sub L equals 0. I'm going to do a little quick math in our head. How many M sub L's are there when L equals 1? 3. How many are there when L equals 2? 5. So we haven't done these other ones yet, but I think you guys have caught on to the pattern. How many are there when it's 3? 7. How about when it's 4? What about when it's 5? So how many total orbitals do I have? 36 orbitals. So how many electrons could that possibly hold? 72. Here's my question. If I have 72 electrons, and it's considered neutral, how many protons should I have? 72 also. If I know I have 72 protons, what does that tell me about the periodic table? What number should I look for? Look for 72, which is hafnium, which is what we're going to do in Chapter 8. Take this information and combine it with what we know about the periodic table and be able to count electron configurations across the periodic table and talk about how do we know that's how the periodic table works. Yeah.
So if you ask for orbitals, find ML and just count them together, and that's not number. But if you ask for electrons,
Double it.
then you find ML and then you multiply that by 2.
Yep.
Okay.
Yep. All right, go ahead and find yourself your group if you're not already sitting